Yep.
All right, everyone. Thanks for sticking it out till almost the end of the day here on the first day at Hadoop Summit. I'm usually pretty full up with information by now. How's that for you guys? Yeah. So my name's Paul. I'm a big data guy at SAS. I've been there for 32 years, so I've seen lots of things come and go. And this Hadoop phenomenon is really a fantastic place, I think, and we at SAS think, to do your analytics. It's a beautiful place to get a lot of data and bring it all together on a single system, and it provides the CPU horsepower to do lots of calculations. So my partner in crime here is Dan, and he's the guy who's done all the hard work on the demos and things like that, so I'll stop talking a little bit and just put little traps in front of us to keep it exciting. But how many of you guys have a data lake strategy? Couple, right? Most people, actually, in my experience, with who've been in Hadoop, have sort of got their hands around their data lake strategy. And they've sort of got their hands around their ETL strategy. How's their ingest going to work? Which source systems do they want to get into their data lake? Maybe they're not 100% down that list yet, but they've got the process kind of worked out, and they can turn it over to the machine, and the people in their organization say, hey, you guys finish this job. We got it started. We've got it working pretty well. Now it's just a case of filling it out for all of the data sources that we might want to do. And the forward-looking, the people who got into Hadoop the first place, they're getting kind of itchy at this point, saying, well, what can we do now? We've got this project sorted out, the Hadoop and the calculation, especially the batch is working. What's the next thing we can try? And a lot of the customers that I talk to, they've got an ambition to do some kind of real-time or near real-time project. What if we didn't have to run a batch report and post the next best offer to a customer profile record, so when he calls the call center, we can put it out there? What if we just calculated while stuff's happening? Or what if we're observing our machinery and one of them develops a vibration, and we've seen that pattern before and we know that it ends in tears? Why can't we send an alert to some infrastructure right now? Hey, machine number 37 is doing that wiggle thing, and that usually ends in tears, so better send a technician over there before something bad happens to that machine. You've got retailers who have ambitions to watch what you put in your shopping basket. So this is for guys that go to the Home Depot or the Lowe's, the retail store over the weekend, and they're obviously doing a project, but it's not their full-time job. So they throw in the tiles and the grout and everything in their shopping bag. They forget something inevitably, right? You forget the little plastic squares, or you forget one of the ingredients in your project. But it's really just a recommendation engine. Look at the stuff that he's got in his basket, and look at all the other baskets of what people have run, and match it to the project he's trying to do and say, hey, you forgot this component. Maybe he's got some from before, but usually the person shopping will say, oh, that's really great. Thank you for suggesting the thing I was about to forget. I'd go home, I'd have to come back and make another trip for that. So there's plenty of opportunity to put the analytics right there in the moment. And we hope to show you with our talk here that Apache NiFi, a great tool for the lightweight plumbing, the data, attach this to this and join it and maybe change it around a little bit, combined with the SAS streaming engine, which we think our strength in analytics, or the recommender engine in this example of the retail. One of my other customers runs an airport. He runs lots of airports, and the planes are in the air, and they can get the radar traces of where they are and when they're at 40,000 feet and when they're down to 25,000 feet, and suddenly they're only 10 minutes away from the airport. But they're trying to predict, when is that plane going to actually touch down, taxi around the airport, you know, get held up by something, a stray dog on the runway or other planes, whatever. But when they finally show up at the gate, that's when the SLAs kick in for the airport. And can they reduce the number of times that they miss on those SLAs? You guys have been on airplanes. You know how frustrating it is to get there. And the guy comes, oh, they've sent us to the back 40 here. We're going to park here for 10 minutes because there's some other airplane at our gate. Can they do a better job at predicting these so they can work around it? All examples of businesses with data that they could process more intelligently, more quickly, and we hope to show you some examples of that. SAS's architecture fits super nicely on the Horton Data Platform. It fits super nicely on the idea that Your data is spread out over a number of servers that you sort of divide and conquer the mass of the problem by moving chunks of the data to many servers, and that the mathematics and the decision making should follow suit. We've been partners with Hortonworks since quite a very long time. I can't actually remember. We are HTTP certified. We do participate in the upcoming releases and the things that they're adding to the platform over time. So I'm going to stop right there. I'm going to hand it over to Dan, who can set up a little bit the problem that we're going to set up here and demo today. And then we'll see if there's any questions from the audience. Feel free to interrupt us anytime. We'll try and field that question and carry on. And I might have a bit of a punch and duty with Dan every now and then if he says something and I think differently about it, or I want to reinforce that point. So this will be the first time we've tried that, so hope you guys enjoy it.
Yep. All right, thanks, Paul. All right, so that partnership that Paul mentioned really extends to HDF, specifically NiFi. So here's the interface. If you guys haven't worked with this, it's a really great product to get up and running and include in your real-time architectures. And there's a couple things to point out really quick is that we have this ability to create this drop and drag interface. I think that's really nice. It's something that you don't necessarily see in all of the open source world, and it's incredibly easy to get up and running very quickly. It supports bidirectional communication. Coming from the NSA, it's secure. There's encrypted channels. And we also have this data provenance layer that allows us to track lineage, look for data as it's moving through this real-time platform, see where it may be stopped, what happened, what were the error messages, how is it transformed along the way. So we have a lot of control over that, and that's exactly why we wanted to extend this partnership and put our real-time streaming analytics into NiFi. So in this case here, it's still that platform, except now I have a data flow, and this is something that I'll show you guys later, or actually very soon here, where we have a data flow going. There's actually two on here, right? There's actually a top one that picks up a data file. In this case, it's just picking up a raw file, inferring the Avro schema, converting it from CSV to Avro, and then it puts that data set, or those events, those Avro events, into a real-time streaming engine from a SaaS perspective. And from there, that's where we can include in and actually run this data stream through machine learning algorithms, both supervised algorithms that you build offline and deploy in real time, or even unsupervised, like k-means clustering and dbScan type clustering techniques. The bottom one here is listening to ESP, which is SaaS event stream processing. It's listening for those events to come from SaaS, which might be your machine learning output, injected into ESP. Maybe it goes through a little processing, does something to the JSON string or something like that, and drops it into HDFS, or maybe you kick out an alert, or write it to some other third-party system. So there's a lot of flexibility here, and here are the two processors that SaaS has worked with the Hortonworks HDF team to build out and deploy in this case. Okay.
And this kind of architecture is super flexible. You probably want to save some of those input streams for backtesting and for model development and for inventing new approaches to things, but you also want to divert the records in real time to the model that you have today. So on the input, you want to save some of it, and it's easy to tweak your NiFi diagram to have a fork in it and say, okay, put all the records here and send all the records onto this black box that makes predictions. And so the NiFi as a controller for the picture or the overview of what's happening or what your idea is a very useful metaphor.
Yep, thank you. Yeah, absolutely. And why is this important, or why do you guys even care? Well, some of you might have SaaS existing in your environment, and in this case here, you can use the tools that we have, whether it's Enterprise Miner, you write SaaS code, or you build it out in a visual environment. You can take this analytics and deploy it in NiFi. Or maybe it's the other way around. Maybe you have NiFi, and you're looking to take it a step further and start to do streaming analytics within the NiFi platform or HDF platform that you already have. This just gives you additional options. And for me, personally, I put those two bullet points or those two line items down below. I think rapid prototyping is incredibly important. I think it's important to build out your real-time architecture, test it out, and be able to iterate very fast. And I think the other point there is that in the streaming analytics world, or really this IoT world or connected devices, being able to connect all these devices and all these platforms and third-party systems is very, very important. So an open framework is something that's necessary from SaaS. It's something that obviously Hortonworks in the open source community is all about. And we just wanted to kind of highlight that here.
Perhaps you guys, some of you went to the 2 o'clock talk from the fellow from Ford who did a NiFi example on his home computer setup. He put a couple of sensors on the doors and a couple of sensors on the windows, and he could tell when the phone had logged into the router, and he was able to basically instrument up his house to when people were home and when people were not home. When did the dogs want to get let out? He did all of that as a project. But he said the same thing. He says this NiFi has got the easiest install program ever. You can download it and get started very, very easily. So back to my thesis that I think a lot of you guys have your data lakes sorted out. You have this kernel of an idea of what you could do for a real-time project, and we're trying to egg you on. Come on, give this a try. Download this stuff. You'll be surprised how quickly you get started with it.
Yep. All right, so what can you do in real time? In this case here, this actually highlights, it's more with a flavor on a SaaS event stream processing, but I think this applies to the streaming engines that are out there, and even some of which you might be working with today. So you have things like filtering, aggregation, pattern detection, in-stream joins, a variety of capabilities that you can do to the streaming data. But then you get down towards the bottom, and what about text analytics? Right? That's really neat to do, just more than word counts or other things with text and pattern matching, but actually go in and look at the linguistics of what's being said. Can we categorize it in real time? Can we take action? Can we extract out entities, look at sentiment? Those are all things that can be done now in real time. Or we have unsupervised learning. I mentioned k-means, dbScan, and then of course predictive modeling. And I actually put that in the umbrella of machine learning as well. So being able to take your random forest models, neural networks, gradient boosting models that you develop offline, train them offline, and deploy them in real time now. And we give you a nice framework to do that very easily. We also have a drop and drag interface. This applies to NiFi as well as the SaaS product, event stream processing. So we have a process flow. You bring data in. It goes through a variety of functions and capabilities. And this is, of course, the PowerPoint representation. And this is actually how it looks in real life, in which I'll show you. But it's drop and drag interface. It's browser-based. You have some of the functions on the left-hand side there. Then you have the workspace in the middle, and on the right-hand side is the setting for that particular function. So if you click on a node, it'll say, hey, adjust these. And that's also very similar within the NiFi process flow as well, right? There's a properties pane or properties window that pops up, and you can edit what's going into that particular window or that block. I mentioned it's very important to highlight the fact that part of why we're up here and part of why we think this integration is so important is because you're able to take those machine learning models and code that you develop and run them in real time. So that's one of the basic things. You can also get very nice pattern matching, joins, all from an interface, right? A user interface that allows, again, for rapid deployment, easy debugging, and I think just it really even extends the ability of your team to develop and kind of work on these real-time models. They don't necessarily have to go down in code, although they can. There's Java and C APIs. There's integration with Python that's coming out. We have a RESTful web service. So there's a lot of ways that you can interact with this, and one of them is this interface. Okay, and I did mention text analytics. I kind of went through that real quick. Just if anyone does have a use case around this, and keep it in mind, even out of the context of SaaS, there are really three things I think from text analytics that's important when you think of a real-time deployment. So one would be categorization. So as data comes in from a call center, from technician logs, whatever it might be, how do you categorize that data, identify the trends in those categories, or even subcategories? The next would be entity extraction, so real-time entity extraction. And this could be useful in log analysis. It could be useful in text. Maybe you want to pull out ID numbers, some other information, even currencies, locations. And the last one would be sentiment. And those are all things that we can do inside real time. This one is where I think the world of streaming analytics is going. I know some that are working on it. I think SAS is a leader in this space, especially from where we are right now in the streaming market, and also from a machine learning perspective. So what this is showing you, this is actually the learning capabilities inside our streaming engine. So one thing here is that this node that's highlighted says W_training. This points to a training data set. And it can be dynamically updated. It can be just kind of sitting there in the static file. But what happens is the system reads that in real time. It'll train your model and then drop it down to this following node here for scoring, so that now new data that's coming through is being scored in real time. And why this is really, really powerful is that you can actually send this data stream, right? If you know the truth or you have some sort of learning output, you can actually feed that back to that training node, and it can adjust and learn as it goes. So it should get smarter over time. It's this feedback loop, and I think this is where a lot of streaming analytics is trying to go, and I think it'll get there in a lot of ways, probably faster than we even realize. Okay, there are front ends for this. NiFi has the graphical user interface. I will show you in 1 second. I'm going to provide a demo. And we have what's called a stream viewer in this case. So it's just a bunch of widgets that are within an HTML interface. You can kind of move them around. And what it does is it allows me to look at any block within my process flow. So I set up that process flow, and that's my real-time process flow. And when I deploy it, maybe at some point I want to say, hey, let me look at that join window and see what data looks like as it's streaming through it. Or maybe I want to see the data input window. Say, what does data even look like when it's being sent to my streaming analytics process flow? So this allows us to do that, allows us to view the results. In reality, I think a lot of people don't necessarily use this except for diagnostics. I think you don't sit there and watch a real-time data feed. It's more, hey, triggering alerts or calling out to other third-party systems, but it's really good for the diagnostic. And if you want to set it up as a user interface, you can do that. You can feed it to your own custom HTML pages through WebSockets, or if you create your own, or maybe you have some other dashboarding tool. Okay, so SAS and NiFi, the integration of these two. So over here on the left-hand side, we have the event streaming in. We have our analytical engine in the middle. And then we might have HDFS on the far right-hand side. We might have alerts. And NiFi is going to be sitting as that platform. And you can use it on the front end, you can use it on the back end, or we can make calls out to SAS event stream processing in a variety of ways. And I'll show you that. Here are some of those adapters that I think are very important. And again, this then extends beyond the idea of just what SAS has, but what is important to real-time models, IoT connected devices. So here's some that, it's just a handful of ones that we think are really important. Okay, and here are also some others. You see a lot of these are open source components. You see Kafka on there, which I think is very essential. You see NiFi. Board Reader is actually a text. It's a data aggregator for like social media and news sites and forums. Flume, Cassandra, and some others. Right? So I think that's really important. And connecting these devices is all very essential to this process. Now, when we think of edge analytics, and I'm kind of transitioning into the demo here. So when we think of the streaming analytics, I usually like to bucket it in these 3 pillars. So one would be edge analytics. And as we build out the solution, as you guys might be architecting the solution, think about, does it make sense, or is there an opportunity to put the analytics out there in the device? Right? Can it go in a vehicle? Can it go out in a gateway? Can it go into some other sensor for health monitoring? These are all things that are coming, or they're already starting to be developed. And being able to put analytics out there at the edge, but also have analytics back at the server, provides a very strong infrastructure and platform for this IoT analytics.
So the connected car guys talked about this. You've all had that check engine light in your car go off, right? But it was wrong. It was a false alarm, or it was a dumb reason. You pulled into the station, the guy read the code and reset it, and off you went. The amount of processing you can do locally is limited, so sometimes your model can't be perfectly accurate, but it screens out 95% of the time you were driving the car, the check engine light didn't come on, and that 5% of where something could be wrong, maybe you should have a check. So the locus of where you do the model is important. You wouldn't have to ship all of those data points from the car up into the cloud 95% of the time just to say, yep, everything's still fine. So this idea that you can ship the data stream of a few cars to learn a good model, to figure out when to light up a code in the check engine and deploy that model down into the edge is being reinforced with the connected car idea of, well, what happens if we get a better model in 3 months that doesn't put the check engine light on as often? Maybe we learn the scenarios where it's a fake, it's a false positive, and we can reload the software in the ECU in the car from the cloud and give it a better set of rules for detecting the check engine light. And that's the feedback loop that he talked about a little bit. Your models are always improving. They go through some kind of QA, but you can put a smarter model back down in the edge, and then you'll get fewer but better indications from that. And you'll still stream some sets of data back up to the cloud to either have a good data set for back testing or to take further action on it, or to implement some other part of your grand plan to do what you want to do.
Yeah, yeah, and that's very expensive, right? To be sending, especially in the scenario for cars, if they're sending it back in real time over 4G, right, a cellular network. I mean, that's bandwidth issues and cost. A lot of things are involved there. So there's a lot of reasons to put the data out at the edge, right? The second use case would be in-motion analytics, and the easiest one to wrap your head around this would be cybersecurity, right? Data isn't maybe out there at an edge device. It isn't back at the server yet, though, but it's actually capturing it in flight or on the network stream. And that could be click streams, it could be logs, it could be a variety of information that's coming through. But we see a lot of potential here. And actually, this is where I would say most customers are actually fairly ready or willing to tackle some problems. The edge analytics is all about getting the hardware in place and the infrastructure, and there's a lot of things that need to be handled there before they can jump on a use case like that. And then the last one there is data at rest. And this is really saying, hey, we can apply real-time analytics, right, with NiFi and ESP in the actual server setting in your environment, but also merge that data at rest with the real-time stream so that you can enrich it, pull maybe from customer database information or service logs or some past information, merge it with that data stream, and then feed it into a predictive model. All of a sudden, that raw information stream just got more powerful because historically there's customer information that you could tie to it.
Yeah, back to my guy at the airport. He's got the planes in the sky approaching the airport. That's one vector of chaos. Things could go wrong. But there's also the fleet of ground equipment and which buses have got broken down today and the passengers are loaded into the buses, and which jet bridge has gotten so rusty it won't move today, so they can't use that gate number 13. All of the local operational conditions, you kind of have to merge that intelligently with what's going on in the sky and which planes are about to depart and have filled out their paperwork and they're waiting for their exit assignment. So now they're going to be congesting the taxiways as they work their way to leave the airport. All of these data sources, it's not really new to the data science folks. More data sources makes you able to build a richer model. And in the real-time case, it's the same trick. You've got to find the appropriate thing to blend in there to give your mathematics more handholds or more hooks to understand the nuances in the data and produce richer models. NiFi is great for that. It helps you bring in extra data sources, merge them together, and present them to either the model scoring phase of it or just collect that data so that you can build models over it.
Yep. Yeah, thank you, Paul. Okay, and here are some of the areas where I think there are opportunities. And these are high-level buckets, but these are what I almost boil down every single real-time opportunity to, right? So we have anything around risk or compliance, right? I think that's very time sensitive. It costs organizations money if they don't detect it, handle it appropriately in a timely fashion. Safety, right? Physical safety or even environmental safety, is very, very critical, time sensitive. You need to be alerted when something's going to, trigger some event that could be a safety hazard. Similarly, security. And again, that could be physical or cyber security. Being able to react to that information and take action on it very quickly is critical, right, to an organization, even to people. And lastly, personalization. And this could be if I'm a very upset customer, I call into let's pick on a credit card company, and I start talking about hey, this happened, that happened. They only have a few minutes to send something to me, maybe not even that long. So, personalization is very time sensitive. Or even if you're in the store trying to buy something, right? If you send me that coupon 5 minutes later, I may have already purchased or walked out of the store, right? Probably walked out of the store. Right? If I purchased, that would be a good thing. So really, it's all about extending the footprint, taking what you're doing in traditional batch processing and seeing where there are opportunities to leverage this real-time infrastructure or technology to improve what you're doing in your current situation. All right, so now I think let's go to the demo. All right, so what I'll do is I want to show you this software. Let's see. Okay. All right, so I do have NiFi up, right? I have that flow that I showed you earlier. You can see the two flows here. For those of you who are familiar with NiFi, I'm going to actually open this up. And you can see that there are some properties that we added, right? So if you're kind of new to NiFi, this might not make as much sense, but I'll try and talk through it so it does for the full audience here. So there's some properties we added. Basically, all you have to tell NiFi is, hey, where do I find the SaaS server? What's the host? What's the IP address? What port is it running on? And what is the project name? Right, the project, the continuous query, and really the window where I can grab data from or wherever I need to send data. That's essentially all you really need to include in this information here. So this is put ESP. So this is actually sending that data stream, that Avro stream, to SaaS event stream processing so that we can run real-time analytics.
Yeah, so maybe that was the one Dan chose to start on, which is really the interface or the boundary between NiFi picking up the data and doing some stuff with it, then handing it off to SaaS. So this node is more custom to that interface between NiFi and SaaS. But the first three squares on that picture are fairly standard stuff. In this demo, something's putting CSV files in a folder. NiFi is watching that folder, it's picking up the CSV files, it's opening them, it's looking to see what columns are in them, that's the second one, infer the Avro schema, and then it's converting the CSV into a different file type. And you just basically choose those boxes off a menu of techniques that NiFi comes out of the box with you, and you wire them up with arrows, and you put a couple of parameters like which folder do you want to watch. And it's got a bunch of cool things to watch this FTP server, and if a file shows up there, grab it. And actually, if something goes wrong, then throw it away and go back and grab it again. And it's got a lot of retry and built-in functionality that doesn't just stop when it gets an error. It has a plan B, or it restarts the operation. It keeps it in flight until it's got it all the way through the pipeline.
Yeah, thank you. And I think that's important to note. So again, just to reiterate that, this put ESP and this listen ESP are the only two really new processors that we put in there from a SaaS perspective. All the others are things that can come from NiFi, when you download it from online. Right? Okay, so I kind of have this flow, right? And Paul described this flow up at the top. So I'm really just going to run this one as part of the demo. Now, if I go to this other screen here, this is actually where I built my connected car demo, the demo that you're about to see, and the process flow. So again, it's a similar process flow where I have different nodes on there. I'm bringing in that data. In this case here, data comes from NiFi. It comes in through this node, and it goes out to several of these others. Maybe it does some aggregation to identify vehicle speed. Maybe it looks at engine RPMs. Maybe it looks at the mass airflow rate, does some sort of aggregation, tries to find outliers as part of that process, and then joins it back with the original data feed, right? And as I click on all these, you can see how the settings is changing over here. In this case, this is a join window, so you can do left joins, right joins. You can set the ID here. Here you see I can actually select different fields. Here's where left, right, outer, full join. And right here is part of what I've been talking about for most of this presentation. So as data comes in through the data stream, it goes to this predictive model flow, or this predictive model window here. And if I open this up real quick, you can see that this is actually the score code that was generated from my predictive model. Right? So maybe I'm an analyst over here. I'm working in SAS Enterprise Miner. I do a drop and drag interface within the SAS Visual Analytics. I get score code from that. And the score code that you see here is the score code that will be automatically generated by those tools. So then all I need to do is put it in this window, right? There's several ways to do that. You can copy and paste it. You can edit the XML behind the scenes and actually just automatically push that into the flow. But once you have that score code in here, now any data that comes through here, whether it's passing through a predictive model you build, a neural network, a variety of other modeling techniques that you use, now it can be deployed all in real time. Okay. All right, so what I'll do is I'll go here. Okay, so this is the last part, and then I'm going to kick off the flow of it. So this is that stream viewer, and this is where in a second you're going to see data flowing through here, right? Hopefully if all works. You're going to see data flowing through, and I set up a bunch of different windows where you can see the raw data stream up top. You'll see the vibration, engine RPMs, and some others. So let me go ahead and turn that on. So I'll hit this here. Okay. So now basically I just started the ESP server. Everything's live. So I'll go over here. I'm going to select the NiFi flow. I'm going to start it up. Okay. All right, go back over here. And now you see data flowing through the system, right? NiFi picked up the file, it converted it, inferred the Avro schema, it converted the CSV to Avro, and now it's pumping it into ESP where it's doing, basically this is looking at the vibration trend, this is looking at engine RPMs. There's a few other things going on here. Down here is the predictive model output. So you see actually the one I'm looking at is this P failure 1. Right? So it's actually trying to say, was there a failure? It's all zeros right now, which really means no failures. Once I get something that is above a threshold that I define, maybe it's 0.8, right? Maybe it's 0.9, 0.95, something that makes sense to my business, then that event will be captured within this window, where then I can send it back to NiFi. Maybe I want to store that value in HDFS. Maybe I want to kick out an email notification. Maybe I even want to write it to some third-party system to do something with or to log the event. So this is all happening, again, in real time. It's very quickly to deploy something like this. And I think it really enhances this rapid prototyping within your organization. Okay. So I think that was really what I wanted to cover. Paul, is there any last comments?
Not really. The dashboard, the middle of this thing is not really the predictive model, but they're quite interesting. They're how is your world behaving, the world that you're modeling, the car that you're observing, or maybe you've got a fleet of cars and what's the average RPM, who's driving the hardest. You could sort of put filters on the data stream to just discover or explore around that you might do with the BI tool after the fact. These are sort of windows on those kinds of counters as it's happening. You'll see that enough time has passed that our demo rig here has kicked out enough vibration that the model says, uh-oh, the wheels are about to fall off, and it's set some of the records that came in, went over the thresholds, and it's predicted that a failure will happen. So that little right-hand box at the bottom has started getting a few records in. And this is where, at the bottom half of that NiFi diagram, it was listening to this window, this bottom left window, and as soon as things start popping into that window, it'll go back to NiFi. And that's the easy point to say, oh, fire this off as a text message to the supervisor. He better go and have a look, or the guard better go and check that the smoke isn't escaping from this expensive piece of equipment. Whatever it is that you're trying to instrument with the prediction when it triggers, you hand it back to NiFi, and he can deal with it. The person can use the drag and drop of that environment to further route the events that get screened out of. There's tons of cars driving all the time, and their check engine's just fine. But then there's one whose light is on, And what are we going to do about that? Well, you need a little more information. You might need the pressures and the temperatures so that you can tell the guy to go to a radiator shop or to a oil change. I don't know, just making that up. But you need to pass a little bit more information downstream, and then from the NiFi diagram, you can decide what to do about that prediction that you put the whole model in place to start with. Yep.
All right. Well, I think that's about it. I know it's probably approaching happy hour, so we'll take any questions if you guys have any questions, and we'll be around. After this, I'm at the booth all week, so you can come see this or more of the NiFi integration as well.
The raw data file?
Yep.
Are you using ESP to parse out the data, or is the NiFi handling that?
NiFi is actually handling that, right? So it's sending the Avro schema into ESP. And there's a schema you define in ESP, so it does say, hey, these are doubles, these are strings, these are integers. But all of the parsing really is coming from NiFi. You could really do it in either, but it's coming from NiFi in this case.
So just to make sure, this is SAS ESP.
Yes.
Right? The other one, which connects stuff, that's what SAS NiFi.
Yeah. So I'll just repeat it for everyone. So just so it's clear, this is the SAS Event Stream Processing Builder, where you build a real-time model, or I should say topology. This is NiFi, right? And this is one of the stream viewers.
Well, that NiFi had the top, which was going into the ESP, and the bottom, where the failures that got alerted are coming back out of the ESP to further be handled. So that although we put it on the same page, there was actually the front half of the process feeding all the events in, and the bottom half of the process only the ones that triggered the model for further handling.
Yep.
Well, what we're saying is the understanding of the shape of the data and putting it into a format is done by NiFi. The black box that decides is the pressure or the RPM sufficient to throw a warning. That's the SAS model that you're trying to feed it through.
Yep.
So that logic is running in SAS. And when SAS kicks out something interesting, that's being handed back to NiFi at the bottom of the diagram.
Yep. Oh.
So what other predictive models and machine learning models does ESP provide?
Yeah, sure. You want to take that first?
You go first.
Okay, so it actually supports, really, we have our Enterprise Miner, which is one of the SAS really premier modeling products that we offer, and really anything that you do from there. So it's anything from basic logistic regression type techniques all the way to random forest and neural networks and ensemble models that you create in there. That generates a score code that you then can put into here. So that's really probably, there's a variety of tools that we have that can help you to
Most of our modeling tools will generate a score code bundle, a model we call it, and any tool that'll generate the model you can deploy. This is one of your options to deploy the model into a stream. You could deploy that model into a Hadoop scoring process, or you could deploy that model into a database scoring process. But this demo was about deploying that model into a real-time, watch the events as they fly by.
And does this ESP only integrates with the NiFi, or it can also integrate with like Node-RED? Node-RED, it's like similar to NiFi, I think.
It can integrate with a wide variety of things. It has a Kafka adapter if instead of pulling it off of raw files, you're pulling it off of your message bus in your organization. It has a big list. He put it up there, but maybe it was too many things to register. It basically can read all of the kinds of data sources that you would have in a real-time scenario. The reason to mate it up with NiFi is that NiFi is actually a little easier to do all the experimentation and to get it just right. Then you hand it over to the modeling to do the prediction.
Thank you.
Sure.
Is that a separate license stream, or is it
event stream processing. Yeah, it would be separate license.
So this ESP, is it software that runs on a single node, or is it a cluster? Does it ever actually get into issues where you have to scale this within a couple more machines or something?
Yeah, so you can scale, so it can run on nodes of the cluster if you want it to. It does run in Yarn, so you can put it, as a Yarn, is deployed in a Yarn container. But typically, the way we'd set it up is you might have several of these set up, and each running, you can define how many threads each one of these are running. And depending on your architecture, it could be, several of them that run different partitions through them, or it could be 3 of them, let's say, but only one is the primary, and the other 2 are kind of failovers, backups. So there's a variety. It depends on your event payload and kind of the architecture of your environment.
So you mentioned the score code coming out of Enterprise Miner, easy to put in here. Would the same be true for contextual analysis?
Yeah, so those are actually separate, right? So that score code is DS2 code, and you could put it in here, but actually, I won't worry about that. There's a compiled file that comes out to .mco and .li file that comes out of contextual analysis, which is our text analytics product, and you can put that in there. You just reference those files. That's it. It's actually easier than score code.
Second question. So this talk was about event stream processing. Do you have similar connections either through Kafka or through NiFi for RTDM, SAS RTDM, or is there a roadmap for that?
Yeah, so that one actually, the connection point is through RESTful Web Service. So RTDM has a RESTful Web interface that accepts events, and ESP sends out basically a post to RTDM. So it can actually run through the analysis, trigger events, send out an event to RTDM, which then receives that payload, processes that in real time, and then sends out an output.
So that's a connectivity between ESP and RTDM. Is there a NiFi adapter to call the RESTful services on RTDM directly?
Yes, you can.
Yeah.
You can. I mean, just plain old NiFi. You can pull web. You can curl things and do web posts and things like that. So
get
you could
HTTP.
fairly trivially interface it to RTDM, which is a REST endpoint.
So if we wanted to do something like that, would we be able to work with one of your team to kind of get, because it would be nice to have like a little, it would be nice to have a put RTDM and listen RTDM node that would be available.
Yep. I think we can. Yeah.
Okay, awesome.
That's a good idea.
So, of the folks who remained, who's going to start a real-time project this week or next week? What are some of the ideas from your areas? What did you want to tune up?
Other question, who's already started?
Who's already started? Well, that is a good question. Who has already started on Chris here from Rogers has a telco. I don't know if any of you other guys have a real-time project in flight. You guys do. Not going to say about what, though. That's fine.
Give me the time's up sign.
Yep. Thank you.
Yeah, thank you.